All right, today we're going to graph quadratic equations. Okay, a quadratic equation is called a parabola when you graph it. And that's spelled P-A-R-B-O-L-A. It's parabola, okay? Quadratic equation, when you graph it, is very much like a linear equation. When we graph lines. When we graph a quadratic equation, the graph itself is called the parabola. A quadratic equation is in the form ax squared plus bx plus c equals f of x or y. Or you could have it written that f of x or y is equal to ax squared plus bx plus c. And that's typically how you would see it. But it really doesn't matter which side the f of x is on. Now, we're going to graph this without using tables. We're going to do this a quick and easy way and understand the parabola instead of using tables and making errors and calculations and coming out with something that doesn't quite look like a parabola. First of all, a parabola, if you were to sketch it, is a U shape. All right, so here's your x and y axis. Your parabola will be a U shape. It'll look something like this. It can go up. It can go down. All right, so I'm going to just put another one right on here. Okay, and it looks like that. It could be wide, it could be narrow, or it could be the same as what we call the parent parabola. We're going to look at that in a minute. So it's a U shape whether it goes up or whether it goes down. And each parabola has either a minimum point at the bottommost point or a maximum point at the topmost point, depending on the direction. Right? So we have a set of rules here, which are interesting because they tell us a lot of information. This value a, that's the coefficient of the x squared term, tells us everything we need to know to graph this without having to use a table and plug in x values and calculate. A tells you the direction. If A is positive, it will go up. If it's negative, it will go down. Its shape will be the same as the parent, wider than the parent, or narrower. So a skinny parabola, a skinny U, a wide U, or the same as the parent. We're going to look at the parent in a minute. And these criteria are what we're going to follow. Every parabola has a line of symmetry. As you can see here, just like the letter U, when you work with symmetry in the younger grades, U is one of the alphabetical letters that you could fold right over itself. Okay, and it will give you the same image on the other side. It would fold on top of itself. So that's a line of symmetry that we're going to find. And we can tell where the minimum or maximum points are, and that value is the y value of what we call a vertex point. Okay, so every parabola is going upwards and has a minimum point, and that's its vertex, or it has a maximum point where its vertex is. Now let's look at a parabola so you can understand all this jargon. All right, first I'm going to try it by graphing a table, using a table to graph. This parabola, f of x equals x squared. That is the parent parabola. Every other parabola is compared to the parent in its size or shape. Okay, so most of the time we refer to it as its shape. A will give us the direction, the line of symmetry, the vertex we'll be able to get from it, depending on the form in which your quadratic equation is given to you. We'll be learning two forms, standard form and vertex form, and we'll be able to tell if we have a minimum or maximum value. So right now I'm going to use a table just to fill in here, okay? And if we plugged in -2 for f of x, all right, equals x squared, f of -2 is going to equal to -2 quantity squared, which means -2 times -2, which is going to give us 4. So that's our first point, -2, 4. Let's plug in f of -1, okay, which means we're plugging in -1 for x and squaring, which means -1 times -1, which is a positive 1. We'll plug in 0 for x, which says 0 squared, which is going to give us 0. So we'll fill in the table. If we were to plug in f of 1, it means 1 squared, which is going to give us 1. And if we plug in f of 2, we're going to get the quantity of 2 squared, which is going to give us 4. Now, as you can see, because of the x values, I chose the y values when they're squared, because y equals x squared. You can see a pattern here. And the reason you can see this pattern is because I happen to know where the vertex is. So I picked 2 points on each side of the vertex. And then we completed the y values to get the final point. So let's graph this. So -2, 4. So we come over to -2 and 1, 2, 3, 4. So we went 2 along the x and we squared it and went up 4. Now we're going to go to -1. So we move 1 along the x, but we squared it and went up 1. 0 for x. We plug in x, we square 0, and we get 0. So we don't move. We're there. Now we go, if x is 1, we move 1 right on the x. We square the x and go up 1, because x squared, 1 squared is 1. If we move 2 along the x, 1, 2, we square that and we get 4. 1, 2, 3, 4. What do you think would happen if we put 3 for x? We move 1, 2, 3 away. What are we always doing to x? We're squaring it. So what's 3 squared? 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be up here. So as you can see, we really don't need a table to do this, because we can make a lot of calculation errors, because our equations for quadratic are not going to look this simple. So if we can use the rule that every time we pick an x value, we wind up squaring it no matter what the rest of the equation says. And that will give us our parabola. Now this is the parent parabola, and a parent parabola always has its vertex at 0, 0. Okay? And I'm going to regraph this so we can do this again. All right, so it's f of x equals x squared. A parent parabola always has its vertex at 0, 0. So I'm going to start writing down the information that you guys are going to have to write down. Okay? So if nothing is added or subtracted after the x squared, vertex is always 0, 0. So I'm going to plot that. Now, I'm just going to start moving. If I move 1 away along the x from the vertex to the right, I'm always going to square the x. So I move 1 x, so I square that 1, I go up 1, because 1 squared is 1. If I move 1, 2 away from the vertex along the x, that's 2 x moves. I square the x, so 2 squared is 4. 1, 2, 3, 4. If I move 3 away from the vertex along the x, the 3 squared gives us 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now because we know this has symmetry, we can move 1 along the left side on x and go up 1. So use our symmetry. We can go 2 and go up 1, 2, 3, 4. And we can go 1, 2, 3 and go all the way up to 9. And then what you do is smoothly as you can, no lines, making a nice smooth curve. You don't want it to look like a tulip. You don't want it to cave in. You don't want it to go outward. You just make a nice U and attach all your points. Okay, and try to nail those points as best you can. And that's your parabola. Again, this is the parent. We compare all other parabolas to the parent. So the shape of a parent is vertex is 0, 0, 1, up 1, move 2 to the right, up 4, 3, up 9. So again, right or left, x moves. x1, up 1. X is moving 2, squared goes up 4. X moves 3, squared goes up 9. If x moved 4, it would square and go up 16. If it moved out 5, it would square and go up 25. And that's how you can graph a parabola without tables. All right, so we're going to keep this here. Now, I know that this shape was upward because my a value, remember, it's ax squared plus bx plus c. My a value was the number 1. So if my direction is 1 or positive, then if my a is positive, my direction is up. So I know this right away before I even start graphing. Now I know this shape is the same because I happen to know that f of x equals x squared is the parent parabola. So I know this shape will be just like this. 1, 1, 2, 4, 3, 9, 4, 16, and so on. Now, the line of symmetry. The vertex is 0, 0, and it's made up of an x and a y. Because our parabola is going upward, we have a bottommost point. This is called the minimum. And the minimum is the y value of the vertex. So what is the minimum? The minimum is 0 because the y value is 0 in the vertex. Now, our line of symmetry. Let's look at our line of symmetry. Our line of symmetry is the line we can draw right through this thing, and I'm going to dash it, and I know it's going to be hard to see because of where it's located. But we're not going to draw this on any of our parabolas, but I'm doing this now to show you. This is our line of symmetry. And our line of symmetry is the x value, of your vertex. And we're going to come to what that means in a little bit in another lesson. But for us, our line of symmetry, and we abbreviate LOS, okay, line of symmetry, is always an equation. And it's x equal, because it's a line of symmetry, and lines are equations. And it's a vertical line, and it is the same value of the x of the vertex. So your minimum value is your y value of your vertex. Could also be a maximum if it goes upside down. And your line of symmetry is x equals whatever your x value was of your vertex. So that A is such a powerful coefficient because it tells us direction, line of symmetry, and the min or max value. Okay, so let's graph another one. Let's graph f of x equals negative x squared. Okay, I can use tables, but I think I'm going to cheat, and I'm going to do it the quick way. First of all, the a value. It's a negative, so it's a negative 1. So a is equal to negative 1. So right there it tells me the direction. And because the direction is negative, okay, then it's going to go down. So right away you're going to write direction is down. So I know my parabola is going this way. Nothing's added or subtracted after the x squared, so my vertex is the next thing I need. It's 0, 0. All right, that's if nothing's added after the x squared or subtracted after the x squared. Now, because it's going downward, I know that I'll have a maximum point, but we can wait till we graph on that. So let's go to our vertex and graph. And the same rule applies. We're always squaring x. Forget about the negative. That told us direction. That's it. We don't need to deal with it anymore. If we move 1 away along the x, we square it and go 1, but because we know we're going down 1. And we can do it equally on each side. If we move 2 away from the vertex and we square 2, we go 1, 2, 3, 4. And we can do that symmetrically on the other side. If we move 3 away from the vertex along the x-axis, we square the 3 and go down 9. So that's 4, 5, 6, 7, 8, 9. And we use symmetry, and be careful, that's in the right place, to graph your other point. And now you connect. Again, it's not connect the dots as in lines. You want to give it a little curve. Arrows on each end because it goes indefinitely. And that's our parabola of f of x equals negative x squared. It's going down. Its vertex we knew was 0, 0. We used that. We graphed 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, pretty big numbers. So that's why we usually stop with 5 points total, the vertex, and then the symmetry of these other 3 points here. Okay. So what we're going to do now is we'll be able to tell the shape. Now look at the shape of this. Does it follow the pattern of the parent, which was 1, 1, 2, 4, 3, 9? And it is. The shape is the same as the parent. All right, so the parent parabola, it's the same shape, different direction. See? 1, 1, 2, 4, 3, 9. Okay. So we got shape, we got direction, line of symmetry, L of S. Because it's a line, it's always x equals. What is it? Take the vertex value of the x, plug it in, done. Does this have a min or a maximum point? Well, it has a maximum because it's going down. It has a very high point. The highest point is here. Okay, so it has a maximum point. So the maximum value is the y value of the vertex. So it's y equals 0. Or you can just write 0. You don't have to write that one as an equation. And we have identified everything we need to on the parabola. The direction, the shape, the line of symmetry, and whether it has a min or max point, and what it is. All right, let's try another one now. Let's spice it up a little bit. Okay, graph of f(x) equals 2x squared. Okay, I could do a table, but there's room for error. So first thing I want to do is I'm looking at the a value, and it's a 2. And if a is positive, because it's a positive 2, its direction is up. So I know this baby is going upward. Nothing is added after the x squared, so the vertex is 0, 0. All right, now, we're always going to square the x, but then after we do that, we are multiplying by 2. All right, so typically our parabolas, based on our parent, everything is compared to the parent. Just like you guys have similarities to your parents, so do the parabolas. All right, so based on the parent, we go 1, up 1, out 2, up 4, out 3, up 9. Okay, well now we're going to double that. Okay, so our vertex is at 0, 0. We're going to go out 1, and we square 1 and go up 1, but this says go twice that amount. So instead of going up 1, I'm going to go up 2 and use my symmetry. If I move 2 away from the vertex on the x, I square that and get 4. But now it says double that, so I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to use symmetry to help me get the other point. And now you got 5 points, and you can graph your parabola. Like I said, it doesn't look like a tulip. It doesn't cave in on itself, but that's it. Now, compared to the parent, let's now look at the shape. Is it the same shape? Or is it narrower, or is it wider? And because the a value is greater than 1, okay, the shape is narrow. And we can see it's narrower. We went 1, 2 instead of 1, 1. We went 2, 8 instead of 2, 4. So it's growing quite quickly. As they say, it's growing exponentially. Now, does it have a minimum point or a maximum point? Well, this point here is our min, and it's based on the vertex of our y value. So it's the y equals 0, and it is a minimum point. And the last thing we need is our line of symmetry, which is always x equals, and it's the value of our x in our vertex. And we have everything we need. We're done. All right, let's look at another one. Okay. If we would graph f of x or y equals negative 2x squared, okay, we're going to do the same thing. One is that it's a negative 2 for the a, so the direction is down. The vertex, because nothing is added or subtracted after the x squared, is 0, 0. And now it's going to go downward. We're going to still square our x value move for the x's, but we'll double it. Now don't worry about the negative because that only tells us down. So we're going to double it. We're going to just use the 2. So we start at 0, 0. If we move 1 away, we typically square and go down 1, but this says go twice that. So we'll go down 2 and use symmetry on each side. We move 2 away from the vertex along the x, we square it, and we typically go down 4, just like the parent, but this says, hey, double that, so we'll go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and use symmetry, and you are all done. And that is your graph. Now, let's get the other pieces we need. The shape. Is the shape narrow or wide compared to the parent? Well, we can see it's narrower. And if it grows faster, it is narrower. Line of symmetry is always x equals, and it's the x value of your vertex. And because it's going down, we have a maximum point all right? And that value is y equals, and it comes from the y value of your vertex. Or you can just say it's 0. So you don't even need tables where you can make errors. And let's try one more, tricky. Okay. And we have an a value of negative 1/4. So since the a value is negative, the direction is down. And because we have nothing added or subtracted after x squared, the vertex is 0, 0. And now let's start graphing. Now, what's tricky about this is if you move 1 out, we square 1, we typically go down 1. Now it's saying go down 1/4 of that. So we're going down 1/4. So what I tend to do is I use numbers that I can divide by 4. So I'll use 2. If I move 2 away, which would be great, right? We square that and we go down 4 typically. But this says go 1/4 of 4, which means go down 1. And that's really all you need, because you need 5 points, because you just want to graph it. It's a basic use. And let's look at the shape now. Compared to the parent parabola, is it wider or narrower? And you can see it's much wider. So the rule is when your a value is a fraction between 0 and 1, it's going to be wide. Okay, so there's your rule. All right, next we need, is it a min or a max? Since it's going down, we have a maximum value, and that maximum value is 0. Taking the y value, or you could say y equals 0. And line of symmetry is next, and x equals the x value from the vertex, and it's 0, so you are all done. And that is how you can graph quadratic equations, parabolas, without a table. It's best to understand how your parabola works. And if you know how it's working based on that a value, and you know your vertex, you can graph every parabola this way, even when we get into vertex form and standard form, which we will learn in future lessons.